Alright, in this video we're going to be looking at measures of central tendency. So notice it says here, frequency tables and graphs show us how data is distributed. This is sometimes referred to as the shape or the distribution of the data. So on example 1 here it says, for the following two data distributions, which do you prefer as a student? So go ahead and look those over. Now, I would say a lot of students tend to give Mr. Jones as their preference. Obviously, Mr. Jones gives lots of A's and B's and not very many F's and D's. And so if you only care about grades, then this looks like an easy A. Now, it's not necessarily the case, but that is the most likely scenario. If you look at the grades here, they're much more evenly distributed. In fact, this is more of a normal distribution for grades when you have grades A, B, C, D, and F. So you can see that getting an A or a B is going to take more work, and you can see most people are getting C's. Now, I think it really depends on what your goal is when you take a course. Like if you're taking some course where, like a history class, and you're not a history major, then maybe all you care about is getting through it, and an easy A is a good thing. But certainly for a math course, like let's say you plan to take calculus someday and you're taking college algebra, then you need to learn something in an algebra course so that when you get to those higher level courses, you'll be prepared. So anyway, something to think about. On the next area here, it says measures of central tendency. So when we start analyzing data, we collect data and we put it in a distribution, a frequency distribution table, and then we go from there to a graph. But often when we're analyzing data, one of the first things we look at is what's average, or what's what we call a measure of central tendency. What's in the middle? So it says here, an average is a measure of central tendency for a set of numbers. 4 commonly used measures of central tendency are the mean, median, mode, and mid-range. And I think most people know the first 3, or certainly a lot of students do. You may not be familiar with the mid-range. But let's go ahead and review these. First of all, we'll talk about the mean. So for most people, when we think of average, that's our understanding of what the mean is. So it says here, to find the mean of a set of data, add the data and divide by the number of data. This is the concept of average that we're most familiar with, which is what I was just saying. Symbolically, we can write the average as follows. So it looks like this. Now, that's probably not the way you've seen it in the past, but certainly if you, like in this course, we're teaching basic statistics. And in a statistics course, this is the way you would see this written. And so this is read X bar. Let's just do this here. X bar is equal to the sum of the data, that's what this is indicating, divided by the number of pieces of data. So you can see that's outlined here. I'm going to go ahead and just write this in a little more detail. So X bar, that's how we say that. That's the mean. And that symbol is the summation symbol. And it just means the sum of the data. And then the denominator is the number of data. All right, so if you look at number 2, X bar is equal to the sum of the data divided by how many pieces of data there are. And so if you add them up and you divide by 8, since there's 8 of them there, you get 544 over 8, which simplifies to 68. Now, one of the things I would ask you here is, actually I guess a follow-up question here would be, is this a good measure of what's average here? A good measure of central tendency? So think about that. Now, if you look at the data, the question is 68 kind of an average test score? Well, not really, because there's 167, so that would be close to this measure of average, the mean. But most of these scores are quite a bit higher than 68. In fact, these two low scores, very low scores, are bringing our mean down. And so maybe this is not the best measure of central tendency here. In fact, I would say this is not a good measure of central tendency in this case. The median perhaps is a better number to use, and we'll talk about the median in a couple minutes here. All right, I would encourage you to do number 3 and then watch the video. Okay, so our X bar is the sum of the data divided by how many pieces of data there are. So if you add these up and divide by 7, you should get 3.0. So you may know that's an average of a B average. So, and that seems like a reasonable average for the data here. We don't have like the 2.0 and the 2.2 are definitely lower than our average, but it's not like number 2 where we have 2 really extreme values. So I want to make a comment here. The mean is considered to be the most sensitive measure of central tendency. Each piece of data is equally measured. So if you have extreme values, it's going to throw off your mean. And so that's why sometimes the mean may not be the best choice for a measure of central tendency. Now, sometimes people will throw out a couple of the extreme values. So here you might throw out those 2 values and then take the mean. So that's certainly a reasonable way to look at the scores in terms of what's really average. All right, let's move on to the next slide. And so now we're going to talk about median. It says the median for a set of data that is ordered, and that's important. The data is ordered, it's in order. It's the middle value or the mean of the middle 2 values. So if you have an even number of pieces of data, you'll take the middle 2 numbers. So for example, we have example 4 here, where you're supposed to find the median. You can see on the first, before I get into that, some examples where the median might be a better choice would be salaries and home prices. And really the reason why that is because you have people that make very little and you have people that make huge salaries, like a CEO, or other people that make very large income. And then the same thing's true with home prices. You have really extreme values, people that have multi-million-dollar homes, and then you have people that are in homes that are worth very little. And so it just tends to be that it's usually better to look at the median when you're looking at things like salaries and home prices where you have extreme values. Okay, so you can see on the first set of data here, the 19 is the middle value. And so when you have an odd number of pieces of data, it's just going to be the number in the middle. And then this is an example here. There's an even number of data here. By the way, you can see one way to check yourself. You can see that there's 3 pieces of data on each side. And so you know you have the middle 2 pieces of data. So we just take the average of those, and that'll give us our median, which here is 78. And it's just the mean of those 2 values, the 2 middle values. All right, so let's look at example 5. So the salaries for the workers in a small company are $34,000, $22,000, $240,000, $42,000, and $30,000. So find the mean and the median of the salaries which measure is the best measure of average for the data. So first of all, I'm going to put these in order. And the middle value is the 34,000, and so that's our median. And then we have to find the mean, so that's x bar equals the sum of the data divided by the number of data. And so that'll be this sum here divided by 5, and you get 73,600. So this is the mean. And I didn't write that down. Let me go ahead and put that in there. So the question is, which of these is a better measure of what's really going on here? And it's pretty clear that we have an extreme value here. And this is inflating the mean. It's making it really bigger than what's really average here. In other words, most of the workers here are not making about $73,000 or $73,600. In fact, $34,000 is a much better number if you look at those other four salaries other than the $240,000. And so you can see that $240,000 really throws the mean off. And by the way, if you told your friend, hey, come work at my place, the average person makes $73,600. Wow, it's like, I think I might be interested in that. That's a decent salary. Whereas if you told them 34,000, that's less than half. So it certainly makes a difference here. So the median is best, and the data value 240,000 is inflating the mean. Notice the two comments I made here. First of all, it says be sure the data is ordered before locating the middle value or middle two numbers. That's one of the common mistakes when people miss a problem on the test. You got to make sure your data is in order. And then second, notice it says the median is not affected by extreme values. We know that the mean is. Notice the median is not. All right, so just to kind of, I want to make one last comment here. The salary $240,000 in this set of data is what we call an outlier. An outlier in a set of data is a data value that's much higher or lower than all or most of the other data. All right, let's go ahead and move on to the next page. Okay, so mode. The mode is the piece of data that occurs most frequently. So on number 6 it says find the mode of the shirt sizes of 8 children in a classroom. Well, let's see. Notice there's 3 10s, and it looks like that's the one that occurs the most. And so our mode is 10. So go ahead and do number 7, and then you can watch the video. All right, so on number 7, notice you have 2 1s, and there's also 2 4s. And so really we have 2 modes, 1 and 4, and this is what we call bimodal. It's even possible to be trimodal, but most often you'll see a mode or a set of data will be bimodal. But it is possible to have more than 2 that are repeating and are the most common. So let's see, if you look at B, there are no pieces of data that occur more than once. And so notice here there is no mode. So it is possible that you don't have a mode. All right, and the last measure of central tendency is what we call the mid-range. It says the mid-range of a set of data is the mean of the lowest and highest data values. So this is actually a quick way to find an average, and we take the lowest and the highest piece of data. By the way, if these weren't in order, you'd want to put them in order first. And so we'll take 4 plus 12 divided by 2. So 16 over 2, and so we get 8. And so the mid-range is 8. And so that's a quick way to get a measure of central tendency. And sometimes people will use the mid-range when they're working with data, and using the mid-range normally gives you a decent number for average, which is not always the case, especially if you have extreme values. All right, so let's move on to the next page. But before we do that, I just want to make a comment here. When we're given an average in the real world, it is important to know which average they're using. So sometimes people are misled because they think of an average as being the mean, but it is possible that someone could give you a different measure, such as the median, and so it's important to know that. All right, let's move on to the next page. So in these last two slides, we're going to be finding mean and median when we have a frequency distribution table, and it just takes a little more work to find the mean and the median. Notice it says here, when many data values occur more than once and a frequency distribution is used to organize the data, excuse me, we can use the following formula to calculate the mean. The mean, or x bar, is equal to the sum of the xf's, that's where you're multiplying each piece of data by its frequency, and then you're adding those values, and then dividing by the number of pieces of data, which is n. All right, so that's what this is all saying right here. So in example 9, it says the table below shows the students' responses to the question, how stressed have you felt in the last 2.5 weeks, on a scale of 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible. This is really a great question to ask students as we approach the end of the semester. Some of you are really stretched, and others maybe not so stretched, but certainly the stress level seems to be a little bit higher at this time of the year. And so let's go ahead and look at this. First of all, I'm going to write, notice in the table the value 0 has a frequency of 2. So what we're really saying is there's two data values of 0. And the value 1 occurs once. And so I'm going to put a 1 there. And the data value 2 occurs 3 times. So I'm going to write 3 2s. And we'll do one more. The data value 3, so people that rated themselves at a stress level of 3, well, there were 12 of those. And so that's the idea. So this table is just basically making it, so that we don't have to write all these numbers out. And so now, and the same thing is going to be true when we're trying to find the mean here. So first of all, if we're going to sum the xf's, we need to find the xf's. So before we do that, I just want to say, notice if you add the 2 zeros, you get 0. And that's like in the table multiplying 0 times, or 2 times 0. So that's just 2 zeros. 2 zeros equals 0. In my little list here, then you have a 1, which adds 1 to your sum. And so we would just, since there's 1, that would just give you a 1 in terms of the sum. That's what this 1 is going to add to our sum. And then next, notice we have 3 2s. And so in the table, we're multiplying 2 times 3, and we're basically multiplying to get that sum of 6. Adding 3 2s gives you 6. And I'll do one more of these. If I were to add my 12 3s, I would get 36. And notice in the table, all we have to do is multiply the 3 times 12, and we get 36. And so we'll just continue to multiply our... So basically that's what we're doing. We're not having to add 12 threes. We just multiply 12 times 3 to get that sum. All right, so we'll do 4 times 16, we get 48. 5 times 18, we get 90. And you can continue the table from there. And so now we're ready to find x bar, or our mean. So x bar is equal to the sum of the xf's divided by n, which is the number of pieces of data. Now the sum of our xf's, we need to add up this column here, and you should get 975. And so this will be, and the frequency, we just add the frequencies up, and that'll tell us how many pieces of data there are. And so we get 975 divided by 151, which is about 6.46. So if 5 is average, you can see that people are a little above average as far as their stress rating. All right, let's move on to number 4. Okay, so here it says finding the median using the positional formula. So the position of the median, it says if n data items are arranged in order from smallest to largest, the median is the value in the n plus 1 over 2 position. So let's see how this works on example 10. It says, listed below are the number of letters in the 9 longest words in the English language. Find the median numbers of letters for the 9 longest words using the positional formula. So the formula is n plus 1 over 2. There's 9 words here. N is 9. I should say there's 9 pieces of data here. 9 plus 1 is 10. 10 divided 2 is 5. And so the median is going to be the number in the 5th position. Again, remember the numbers have to be arranged in order. In this case, they were. All right, so 1, 2, 3, 4, 5. And so the 28 is going to be our median. Now on 11, you should first, well, it says find the median of the quiz scores using the positional formula. So if the first thing you're going to want to do is put the scores in order, which is what I've done here. And then we're going to want to find where the median is in terms of its position. So again, we'll use the formula. In this case, there's 14 pieces of data. So 14 plus 1 divided by 2, you're going to get 7.5 there. And so the median will occur between the 7th and 8th numbers. So let's go ahead and number these. You can see that the 12s are in the 7th and the 8th position. So really we want to take the median of 12, or well, I should say the mean of 12 and 12. Well, that's just going to be 12. And so that's our median here. Now I would say for both of these problems, you probably could have found the median without using this formula, but it definitely comes in handy on the next problem. So let's go ahead and look at the next problem. Again, our formula is n plus 1 over 2, and if you add up the frequencies, that'll give you the number of pieces of data. So that'll be 151 plus 1 over 2. And so 152 over 2 reduces to 76. And so the median will be in the 76th position, or it'll be the 76th positional value. Now, I did what I did before here. I made a list of the first 3 pieces of data and how many times they repeated, or their frequency. So there were 2 zeros, there was 1 1, there were 3 2s, and then 12 3s. It's actually for the first 4 pieces of data. And so in this case, we're trying to find the 76th position. And so let's just look at a couple things here to figure out where that would be. So you can see the second 0 in our data would be in the second position. Of course, the 1 would be in the third position. Let's see, the last 2 would be in the 6th position. It's the 6th number in my list. And you can see that the last 3, you can count it, would be in the 18th position. So let's see how that, we don't really want to do this with the table, because you can see, the 4 repeats 16 times, the 5 repeats 18 times. We just don't want to continue to do it the way I'm doing it here. So let's see how we can do it in the table. So the second 0 is in the second position. And then we said the 1 is in the third position. Notice 1 plus 2 here gives you that 3. And then if we look at the 3 or the 2s, the last 3 would be in the 6th position. And again, notice 3 plus 3 gives you that 6. And so we can do it one more time using the example, or what I've written here. And you can see that when you look at the 3s, there's 12 of those. The last one, we said, is in the 18th position, and notice that's 12 plus 6. And so each time we just add these numbers. So the last 4 will be in the 18 plus 16 position, which is the 34th position. The last 5 will be in the 18 plus 34 position, which is 52. Now we're not quite to the 76th. Let's go again. There's 13 6s. The last 6 would be in the 52 plus 13 position, or the 65th position. We're still not high enough. And if you add 31 to 65, then the last 7 would be in the 96th position. So finally we can see that it's going to be a 7. Our median will be a 7 here. All right, and that's the end of this video.